Here's Mrs. D's transformation board just in case you want to see what I would write. We'll start with the a value. It is the number that would be in front of the equation, completely in the front. If the absolute value of a is greater than 1, it is going to do a vertical stretch by a scale factor of that a value. It's going to get closer to the y-axis. And a lot of times people say in this case that it gets skinnier, especially if you're looking like at a quadratic or a cubic function. It makes it go closer to the y-axis. And if you're looking at a trig function like a sine or cosine, it makes the function taller. So it just really depends on what type of function we're talking about. If the absolute value of a is between a 0 and a 1, we say that there is a vertical compression. That's how we would write that by a scale factor of a. It gets further away from the y-axis when you're looking at a quadratic or a cubic. In other words, we usually say the function, it appears wider. And if we're talking about a trig function like a sine or a cosine, it would get shorter. And so those are some of the descriptive words that we would use. If a is less than 0, it does the same thing to every function. It's going to reflect it over the x-axis. The next letter we're going to talk about is b, and my b value does a horizontal compression or stretch along the x-axis. And what happens if I have the absolute value of b and it's greater than 1, it's going to do a horizontal compression. Means that it's sending that function away, it's compressing it away from the x-axis. So it's actually going to make the function look skinnier. Now if it's a sine or cosine function, we're going to get into this in trig functions, it actually calculates a period or frequency. And if that, as that b gets bigger, the frequency, the function actually repeats over a shorter amount of times more often. So it looks a little bit different. If you look at the absolute value of b and it's between a 0 and 1, we're going to call that a horizontal stretch. And what it's going to do, regardless of the function, it's an absolute value or a quadratic or even a trig function like sine or cosine, it's going to stretch that function out on the x-axis, and that function is going to look wider. And again, if b is less than 0, we would say it's a reflection over the y-axis this time. It's going to do a horizontal reflection over the y-axis. Again, we're going to discuss the b value in more depth tomorrow because it's really a pre-calculus topic, and in Algebra 2 we mainly focused on the a, h, and k. The next letter that we're going to look at is the h, which does a horizontal translation on our function, and it is inside the parentheses with the x. And we also need to remember that there's a minus here. So if I have a positive h, that would be more in the first quadrant, it's actually going to move right, but inside the parentheses it would look like this, an x minus h. And to move left, you would have an x plus h, because you're moving toward the more negative territory, and a negative and negative would make that positive right here. So it would be an x plus h. Again, it's a horizontal translation. It moves left and right like a horizontal painting or like the horizon. And we say this is a little tricky because the plus h goes left and the minus h goes right. Our very last letter is the k that's tacked on at the end. This k causes a vertical translation, and I say that this k is true to itself. And why is it true to itself? Well, unlike the h value, if the k has a plus k at the end, it's going to send this function, translate this function up, so the graph would go up. If it's a negative k, it's going to translate the function down, so the graph would go down k units. This concludes our review of transformations, and now you should go to the question and answer portion of our review and make sure that you can answer all the questions about transformations.